In this video, we're going to look at the graphs of sine and cosine, and we're starting to look at the graphs of all trig functions and all the different ways we can graph them and the changes and transformations that can happen. But today we're going to look at just kind of the basics of sine and cosine and the basics of those graphs and a few basic changes. Now, first, we need to talk a little bit about the graph paper that we use. It's not normal graph paper. Now, here is a view of this graph paper. Let me kind of make it smaller. It's kind of hard to see. So let's look at a blow-up of this. Now, as you look at the blow-up of this paper, I have a few numbers on here that aren't on the paper normally. Pi over 6, pi over 3, 2 pi over 3, 5 pi over 6 are normally not on our graph paper. It's just pi over 2 and pi. That's all. Now, I do this to show you, we're going to look at the scale. If we look at the y scale, we can see that it's 0.5. It goes up a half, 1, 1.5. The x scale goes by pi over 6. Now, once again, I feel better with degrees. So this is 30, 60, 90, 120, 150, 180. So it may help you to think about that in terms of degrees. But once again, with graphing trig functions, we need to stay in radians. Now, the way this works out, let's look at pi over 6. If we were to put this in a calculator and we do pi divided by 6, that equals 0.5235. So this is almost a half. It's a little bit more than a half. So you can see our scale, the y scale is 1/2, the x scale is 0.52. Really close. So if we want to look at, say, well, where's 3? We can basically say that pi is about 3. I mean, our dots are not that accurate. You know, if I say put a dot on the y-axis at 3/4, 3/4, it's going to be about right there. We're not that accurate. So basically our scales are a half both directions, the x and y. Because the 200ths is not much when we're talking about trying to graph on this graph paper. Okay. All right, we want to look at the graph of sine. Now, to look at the graph of sine, I first want to think about the graph of sine in terms of our unit circle. So let me just kind of show you on our unit circle here. If we picture our unit circle, and we know that sine is our y-coordinate. So if I have an angle, 30 degrees, my y-coordinate, you can see here, is this green line. I'm not sure I can zoom this in or not. Nope, not going to really get any closer. This green line is my y-coordinate. So if I'm at about 60 degrees, 65 degrees, that green line is my y-coordinate. And you can see the green line over here. So we start at 0. That's the key. Sine starts at 0. And then as our angle gets bigger, my y value gets closer to 1. And at pi over 2, it's 1. You can see over here. Once I cross over pi over 2 and I go towards pi, it gets smaller to 0. So you can see that green line matches up over here. Once I go past pi over 2, or excuse me, pi, now that green line goes down, so it's negative over here. As I continue on, once I pass 3 pi over 2, it's still negative, but it's coming back up to 0. So you can see my sine curve, my sine wave as it sometimes is called, is basically unwrapping my unit circle to get sine. So if we graph sine, okay, here are a few of the points that were important. Sine starts at 0. At pi over 2, it's at 1. At pi, it's back at 0. At 3 pi over 2, it's at negative 1. And at 2 pi, it's back to 0. Those points right there are what I call the 5 key points of the graph of sine. Those are the points you have to know where they are to graph these. Now, we could do other points. 1/2, square root of 3 over 2, square root of 3 over 2, 1/2, negative 1/2, negative square root of 3 over 2, negative square root of 3 over 2, negative 1/2, and get our curved sine curve. Now, if we think about this, what happens if we keep going? What happens if we go all the way around and we keep going? You can kind of see this is just going to keep going. This graph can just keep going and going and going. Likewise, once we get to 0, we can go negative, and it keeps going. So when we graph this, we need to understand that really this graph goes forever. We have this wave. Very good job graphing there. But this wave goes forever. Now for us, we're only going to look at the red part here. We're only going to look at one period, as it's called, we'll talk about later, with the sine. We're not going to worry about, if you can do the red part, you can just repeat that over and over and over and over and over again. So there's sine. So there's cosine. Cosine's different because it's not the y-coordinate, this green line right here. Cosine is the x-coordinate. So it's this red line. Now, cosine is different. Cosine starts at 1, and as I go around and I get close to pi over 2, it gets smaller and smaller and smaller. It's 0 at pi over 2. Then it's negative to negative 1 at pi. Then it goes to 0 at 3 pi over 2, and then it's back to 1. So with cosine are 5 key points. The 5 points that you need to remember on cosine is it starts at 1, at pi over 2 it's at 0, at pi it's at negative 1, 3 pi over 2 it's at 0, and 2 pi it's at 1. And once again, you could do square root of 3 over 2, 1/2, negative 1/2, negative square root of 3 over 2, negative square root of 3 over 2, 1/2, 1/2, square root of 3 over 2, to get your nice curve. But the points I'm really interested in are those 5 key points. Now, when you draw this, try to make it curve the best you can. Just don't do like a V. Try to make it a curved line. And likewise, cosine goes forever. But just like sine, we're mainly looking at one wave, so to speak, one wavelength. Okay. Now, it's hard when we graph it on the calculator because it's hard to see these points. So these we really can't do easily on the calculator. We really need to try to graph these by hand. But with that said, I want us to start trying to experiment this on the calculator. So what I'm going to do is I'm going to give you a couple of problems here, and I want you to graph these on your calculator to see what happens. So first off, important thing is set your calculator to radians. Okay? So when you try graphing these, set these to radians. The other thing is to see it well, go to zoom number 7. That's zoom trig, and it'll just make these graphs appear better. So we're just kind of looking for some general ideas of what happens here. So first off, I want you to graph y equals a sine of x, and I want you to change this A to 1, 3, 1/2, -2. And try to determine how does that change your graph. What does that changing that A out in front, how does it transform your graph? So I would like you to pause the video now and try those 4 on your calculator. So once you've come back now, you've tried those 4, what do they do? Well, that changes the peaks and valleys of your graph, doesn't it? When A was 1, it looked just like this. But if A is 3, what that does is it changes your graph. It now goes all the way up to 3 and down to -3. Notice, the zeros don't change, just the peaks and the valleys change. So that is what these numbers in front do. They change what's called the amplitude. The amplitude is how high or low our graph goes. It's our peaks and our valleys. And this number in front is our amplitude. Now the negative flips it over the x-axis like it did when we did our parent functions, which this was one of our parent functions. But now that number in front just kind of multiplies our peaks and our valleys. If we have a 1/2, it actually makes our peaks and our valleys smaller, shrinks them. It has a 3, makes them bigger. So that's our amplitude. So let's look at graphing this. First off, we want to say the change here is our amplitude's 2. So we think cosine. Well, think of our 5 key points of cosine. I'm going to put them here lightly. Cosine is 1, 0, -1, 0, 1. No other way to say it is you have to memorize those 5 points. For sine and cosine, you just have to know where those are at. Now, what happens then is any point that's 1, now, because of our amplitude change, goes to 2 or -2. Our zeros stay the same. So now we connect the dots, a nice curved line, and there is the graph of 2 cosine. -3 sine. Once again, let's put the dots for our normal sine. 0, 1, 0, -1, 2. Now, our zeros don't change when our amplitude changes. Now, our amplitude is now 3. So that means our peaks and our valleys are going to go to 3. Since it's negative, though, flips them over. The positive 1, peak becomes a valley, and the valley becomes a peak. And we connect our dots with our sine curve. Okay. All right, we're going to try another one on our calculator. This time, we want to switch this B right here on our calculator. So, go ahead and try these 4, pause the video, try these 4 on your calculator, and see what happens when we change B. So what happened? Well, when B was 1, it's just the same thing that's happened, right? But when B is 3, it really changed the way the graph looks. It's no longer the same cosine. What happens is, still starts at 1, but now we have a shorter wavelength, higher frequency, so to speak. What it's done is it changes our period. That's what this is called. This is a period. Oop, wrong one, sorry. This is a period change. Now, what do we mean by a period change? Well, let's look at this. If we look at sine or cosine, and let me graph sine. From 0 to 2 pi, that is one period. If I would continue on, I'd get the same graph. Right? If I continue my graph, I just repeat itself. Up, down. Just the same thing over and over again. So this is known as one period, from 0 to 2 pi. Now you notice, if we think about our graph of sine and cosine, all I need to do is just slide this over, and now that's cosine. Starts, I got to finish up a little bit to get to here. But really, these are the same points. Just kind of sliding them left and right. Cosine, sine, cosine, sine, cosine, sine. They're very similar. The same period, the same wavelength. So this value b here changes my period. And the way it changes is it takes 2 pi and I divide it by that b. A in front is still my amplitude. Excuse me. So let's look at an example. Sine of 2x. Now my amplitude, there's really no change here, it's just 1. That's what it normally is. But as I look at my period, it's 2 pi divided by 2. That's my b. That tells me my period is pi. How does that change my graph? Well, normally sine starts at 0, still does. Normally it ends at 2 pi. Now it ends at pi, because that's my period. Now this is where we really have to know our 5 key points and how they get changed. Now in the middle is my other 0. In the middle of the first 2 is where I'm at 1. The middle of the second 2 I'm at -1. And now my graph is kind of shorter. My wavelength is not as long because I've changed the period. Now, one way to think about this is if there's a 2 here, what would happen is if I graphed this, I now have 2 from 0 to 2 pi. I now have 2 graphs of sine. The red is only our graph that we're worried about. Let's try this one. My amplitude's 1, no change there. My period now think of this as cosine 1/2 x is 2 pi divided by 1/2, which is 4 pi. So that means my cosine starts at 1, doesn't end at 2 pi, it ends at 4 pi. In the middle of cosine, it's at -1. Here it's at 0. Here it's at 0. So now my graph, if I can draw this, which I'm not doing a very good job, nice and curved, is this really long wavelength. Try another one. Y equals 2 sine of pi x. So my amplitude, I got an amplitude change, is 2. My period is 2 pi divided by the number in front of the x, which is pi. So my period is 2. So let's see, how do I graph that? Sine starts at 0, ends at 2. Well, remember, these are about a half. So a half, 1, 1.5, 2. That's where it ends. In the middle, it's at 0. Between the first two, it would be at 1, but my amplitude is 2. Between the second two, it would be at -1, but my amplitude is -2. So I get my graph of my 2 sine of pi x. We're ready for the homework. Trig Graphs 1.